Find the derivative of y equals 1 plus 2 over x times 2 minus 1 over x, then evaluate y prime of 2. So y is the product of two functions, 1 plus 2 over x times 2 minus 1 over x. One option is to use the product rule, but if you can physically take the product, it will be quicker and easier. The product rule can overcomplicate it. We can take the product by FOILing this out. So let's go ahead and do that and see what we have after we FOIL it. First, 1 times 2, that's a 2. Outside, 1 times a negative 1 over x, that's a negative 1 over x. Inside, 2 over x times a 2, that's a 2 over 1, so 2 over x times a 2 over 1. You multiply the numerators, 4. Multiply the denominators, x times 1 is just x, so 4 over x, positive. And then last, 2 over x times a negative 1 over x. Multiply the numerators, 2 times negative 1 is negative 2. Multiply the denominators, x times x is x squared, so negative 2 over x squared. Now the middle terms, the outside and inside terms, can combine. We have a negative 1 over x and a positive 4 over x. Let's combine those together. So y is going to equal 2 plus 3 over x, and then minus 2 over x squared. So y is made up of, at this point, 3 terms that are adding or subtracting with each other. Each of their derivatives can be done individually. 2 of the terms are in a fraction, but one of the positions, the numerator, is a constant, so we can take the x and move it to the numerator as a negative exponent. Let's go ahead and do that. So we can rewrite this as 2 plus 3 times x to the negative 1 power, and then minus 2 times x to the negative 2 power. Move them to the numerator as a negative exponent. And that way, the second and third terms can follow the power rule in the derivative. Let's now find the derivative, y prime, which can also be called dy dx, equals to, the first term is a constant with no x's. Derivative will be a 0. Second term is a power rule. Bring down the negative 1, multiply with a 3. That will be a negative 3. And then subtract 1 from the power, x to the negative 2. The second term, bring down the negative 2 and multiply with the negative 2, so that'll be a positive 4. And then subtract 1 from the exponent negative 2. Negative 2 minus 1 will go to a negative 3. At this point, it's probably best to rewrite by moving these negative exponents into the other position, which means to move them back to the denominator to make them become a positive exponent. So we will have a negative 3 over x squared plus a 4 over x cubed. So there is our derivative, and now we need to evaluate y prime of 2. Y prime of 2 means to plug a 2 in for each of the x's, so we will have negative 3 over 2 squared plus 4 over 2 cubed. Negative 3 over 2 squared is a 4, plus 4 over 2 cubed, 2 times 2, 4 times 1 more 2, 8. Now we can reduce the 4 and the 8, and they can cancel down. They can cancel by a full factor of 4, so you can do that. If you cancel out the 4 here, it'll be left with a 1 and a 2 here. But we will need to get a common denominator between these two fractions. The answer will be expected to be a single fraction when you have fractions adding or subtracting each other. The common denominator will be a 4. So I'm going to multiply the 1 over 2 times a 2 over 2. So I will have a negative 3 over 4 plus a, multiplying numerators and denominators, 2 over 4. Negative 3 over 4 plus 2 over 4. 2 minus 3 is a negative 1. And we're ending up with a negative 1 over 4.